Alright, in this video here we're going to take a look at a word problem that involves a quadratic equation. So a lot of students are fearful of word problems or just flat out don't like word problems. As long as you read it carefully and you understand what the variables represent, it's really not that bad. Alright, so this one here, we have an object thrown or fired straight upward at an initial velocity of v sub 0 feet per second will reach a height of h feet after t seconds, where the equation for that is h equals negative 16t squared plus v sub 0 times t. All right, so this is a formula from physics. If any of you have ever taken a physics class, you've probably seen this before. But it's the formula that relates how high something is if it's flying through the air, basically. So we have a bullet that's shot straight up with an initial speed of 800 feet per second. All right, and what we want to know for the first part here is when will it fall back to the ground? All right, so it seems pretty straightforward. So the first thing, we have understand what your variables represent, right? H here represents the height of your object, in this case a bullet, measured in feet, right? So it's important to know what the variable represents and also what the units are on that variable, right? So H is the height above ground in feet. T is the time that thing is or the length of time that is in the air measured in seconds, right? And the v sub 0 is the initial velocity in feet per second, right? And then this is the equation that relates all those things. And here they tell us the bullet is shot straight up with an initial speed of 800 feet per second. So they give us that initial velocity, right? So my height is equal to negative 16t squared plus 800t, right? I understand that the v sub 0 in this formula is feet per second. That's my initial velocity. They tell me that the initial speed, remember, speed and velocity are, they don't mean exactly the same thing, but in this case they do. Right, the initial speed is 800 feet per second. Notice that the units match up. V sub 0 is feet per second. This is 800 feet per second. I put that 800 here in place of the v sub 0 in the formula. Right, so in this instance, when this bullet is shot straight up with the initial speed of 800 feet per second, this is what the equation looks like. Right, if I kick a soccer ball up into the air, it's not going to have an initial speed of 800 feet per second. It might be like, I don't know, 20 feet per second or something like that. I would put that number 20 there for the v sub 0, right? So again, understanding what the variables represent, looking at the numbers they give you to make sure that you put the right number in the right spot, all important things when you're solving a word problem. Right, now, to answer this question, when will it fall back to the ground? All right, so when this bullet falls back to the ground, what is its height going to be? Well, when it hits the ground, it has a height of 0, right? So h is my height, so in order to find out how long it's going to take until it hits the ground, I have to plug in 0 for my height, right? When it's asking me when, right, it's asking me how long it's going to take, it's asking me to solve for time, which is t, right? So again, reading the problems carefully, what is it asking me for? Is it asking me for the time? Is it asking me what the height is going to be at a certain time? If the question says, well, what is the height going to be 2 seconds after you shoot it? Well, they're giving me the time of 2 seconds and asking me for the height. I would plug in that 2 seconds for t and then calculate to figure out what the height is. Right, this time though, they're asking me when this is going to happen, so they're asking me to solve for time, which means I need to plug in a number for h, and so when we hit the ground, that's a height of 0, so 0 is a number that I plug in for h. All right, again, understanding what the variables represent, reading what the problem is asking you for, understanding what variable they're asking you to solve for. Are they asking me to solve for time? Or are they asking me to solve for height? Are they giving me the height? Are they giving me the time? Make sure you put the numbers in the right spot. The easiest way to screw up a problem like this is to just put numbers in for the wrong variable, and then you're pretty much lost from there. Right? So my height is 0, and I need to solve this for t. And what I end up with here is a quadratic equation. Right, I have 0 equals negative 16t squared plus 800t. So since I have a t squared, that makes this a quadratic equation, which means I need to use a method for solving quadratic equations. So that means either factoring or the quadratic formula. Right, the square root method won't happen here because I have this t to the first power involved. So basically, I'm down to either factoring or using the quadratic formula. And this one, since there's only 2 terms, I'm definitely going to be able to factor this, right? Which is what I'm going to do. All right, so factoring, since I only have 2 terms here, if I want to try to factor this, it's not going to be one of those trinomials with the 3 terms where I set up the 2 parentheses and I find 2 numbers that multiply to this and add up to that. It's not set up that way, right? There's only 2 terms here. So if I want to factor something that only has 2 terms, well, it's either going to be a difference of squares which this is not because the 800t is not a perfect square, or I can factor it using the greatest common factor, which I'm going to be able to do here. Right, so I look at my negative 16 and my 800. So those have a common factor of, let's say, negative 16. Right, and then I also have a t squared and a t, so those two have a common factor of t. Right, so if I pull out the common factor of negative 16t, it's going to leave behind just a t for that first term, right, because negative 16t times t would give me negative 16t squared. And then for the 800t, let's see, what would 800 divided by 16 be? I think that's going to be 50. I hope that's right. When I say things in that high tone of voice, that means I'm not really sure. I do have a calculator here, so let me just double check. If I do 800 divided by 16, that is 50. Okay. All right, so, but it's a negative 50 here, correct? Because I pulled out the negative 16t, so I would have to have a negative 50 here, so that when I multiply negative 16t times negative 50, that's positive 800t. All right? So that is my factoring, and then once I factor this, I can break apart my factors and set each one equal to 0 and then solve each one for t. Right? So I have my first factor here is this negative 16t. All right, so I have negative 16t equals 0, and then I have t minus 50 equals 0. All right, so if I solve negative 16t equals 0, I divide both sides by negative 16, and 0 divided by negative 16 is still 0, so I get t equals 0 seconds. All right, and for this one, if I have t minus 50 equals 0, if I add 50 to both sides, I end up with t equals 50 seconds. Okay, that's still on the bottom of the screen there. Okay. So I end up with two answers, like we see with most quadratic equations, I end up with two answers here. So which one of those actually answers the question? Well, when will this bullet fall back to the ground? It's not going to be at 0 seconds, right? 0 seconds is when you actually shoot the bullet up into the air. So that's a valid solution to my equation, right? At 0 seconds, it has a height of 0 feet, assuming that you're shooting the bullet from ground level, right? So it has a height of, or it has a height of 0 feet at 0 seconds, because that's the instant that you pull the trigger and shoot the bullet up. But then it goes up into the air and then it comes back down, and 50 seconds later is when it hits the ground again on its way back down. So my answer to this question, when will it fall back to the ground, is just the t equals 50 seconds. Right? So even though we get two solutions to the equation, only one of those solutions is actually the correct answer to the question they asked us. So make sure you're thinking, but that's the other thing about doing the word problems. You know, once you set up the mathematical equation and you get that part squared away, which for a lot of students, that's the hardest part, is just getting the equation set up that you need to solve. Then doing the math, I mean, once you have that set up, it's just like solving any other quadratic equation that you work with. So if you know those methods, you just go ahead and do that. But then once you get your answer, you have to think again. Right? All right, so I have two answers. Which one of these answers the question and which one doesn't? Right? Because it's not going to fall back to the ground 2 times. It only falls back to the ground once. Right? The first one is when you first shoot it. The next one is when it actually comes back down to the ground. All right, so that's one example here of solving this problem. What I'm going to do here is pause the recording and erase this and put up like a part B of this problem where we solve something kind of similar. All right, so I erased all the stuff up there. I also erased all the words because that took up most of the board and didn't really leave us a lot of space to actually solve the problem. But recall, we're shooting a bullet up into the air. This is the equation. You know, it had an initial velocity of 800 feet per second. So the equation that models the height in feet is equal to negative 16t squared plus 800t, where t is the time measured in seconds after you shoot the bullet up into the air. And part B here asks us, when does it reach a height of 2 miles? All right, so once again, paying attention to what your variables represent, right? H is the height, T is the time. I'm not going to plug the 2 miles in for time, right? 2 miles is not a unit of time. That doesn't make any sense at all. Don't plug in 2 miles for T. It just doesn't make sense, right? 2 miles is my height, so I need to plug that number in for H. But be careful, right? Remember, H is the height of the bullet measured in feet. 2 miles is not feet. It's measured in miles, not feet, right? So we also have to be aware of the units here. It's not something you see all the time, but every once in a while you see a problem like this that tries to trick you. I'm not just going to plug in a 2 for the H, right? Because my H has to be measured in feet. So the first thing I have to do is change 2 miles into feet and then put that number in place of the H, right? So if I have 2 miles and I want to change that into feet. So if you know how many feet are in a mile, it's 5,280. So in 1 mile I have 5,280 feet. And this is actually something that my chemistry teacher in high school taught me as far as converting units. It's like the only thing I remember from the chemistry class that I took in high school. But you start with whatever your unit is, 2 miles. You multiply by your conversion factor, right? In 1 mile, there's 5,280 feet. When I set up that fraction there, I need to cancel out the miles, so I put the 1 mile in the denominator and the 5,280 feet in the numerator. And so to get this, I have to multiply 2 times 5,280, which would be 10,560 feet. All right, so that would be the number of feet in 2 miles. And once again, I'm going to reach for my calculator just to make sure that I did that correctly. 10,560, yeah, okay, good. All right, so that's how many feet are in 2 miles. And so if I want to know how long it takes for this bullet to reach a height of 2 miles, I need to plug in for my h in my equation the 10,560 feet. All right, because remember, h is measured in feet. I can't plug in miles for feet. Just like it doesn't make sense for me to plug in miles for the time, it also doesn't make sense for me to plug in miles for my measurement of feet. Right, so I have 10,560 equals negative 16t squared plus 800t. Not looking like a fun equation to solve. Some of those numbers are pretty big there, but we deal with it. Right, so I have once again a quadratic equation I need to solve. So what I'm going to do now is subtract this 10,560. You know what? Well, yeah, I'll just subtract that over to the other side. I'll make it 0 equals negative 16t squared plus 800t minus 10,560. Right, and now maybe I could factor this. I am not even going to try. Right, since I have this number here in front of that 16, like I would have to use the AC method, and if I multiply negative 16 times negative 10,560, I would have to find two numbers that multiply to that and add up to 800. I might be sitting here all day looking for those numbers, right? So once the numbers get so big, I tend to not factor. I shy away from trying to factor things like that, and I'm just going to go ahead and use the quadratic formula, right? So in this case, my variable t is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2 times a. All right, and then my a is the negative 16, my b is the 800, my c is the negative 10,560. And once again, I'm going to have to go up here and erase some of this stuff so I have enough room to plug this stuff in and actually try to solve this equation. All right, so my variable t is going to equal negative b, so negative 800, plus or minus the square root of b squared, so 800 squared, and this is definitely one where I'm going to use a calculator to figure it out, minus 4 times a, which is negative 16, times c, which is negative 10,560. Yikes. All right, all of that over 2 times a. All right, so when you're doing one of these problems and you end up with huge numbers like this, don't say, well, these numbers are really big, so this is going to be hard, so I'm just not going to do it. Put the numbers into the formula. It's not that bad, especially if you can use a calculator on it, which for a problem like this, I would definitely advise you to use a calculator. So let's see what we get inside that square root. I'm going to do 800 squared, and then minus 4 times negative 16 times negative 10,560. And I get negative 35,840, just to show you what I typed in the calculator there. All right, so I did the 800 squared minus 4 times negative 16 times negative 10,560. I get negative 35,840. So that's what I have inside that square root. All right, so I have t equals negative 800 plus or minus the square root of negative 35,840. No, yeah, 840. And all of that over 2 times negative 16, which that one I can do in my head. That's negative 32. Right now, if you recall from when we did these problems with the solving quadratic equations using the quadratic formula in one of the other videos I did, if I end up with a negative number inside that square root, I have no solution, right? Because the square root of that negative number is not a real number, which means that there is no solution to this equation, right? So anytime you're using the quadratic formula, this comes out to a negative in the square root, you can just stop there. There is no solution to this, which means that this bullet is never going to reach a height of 2 miles, right? When you shoot it up into the air, it's just not going to go that high. It is going to stop and come down before it reaches that height of 2 miles, right? So there's no solution to this equation. All right, so that is solving a word problem that uses a quadratic equation. Again, paying attention to what the variables represent, pay attention to what the units are, and make sure you plug the numbers in the right spot are the keys to doing a type of problem like that.